Sorry, come on. For one part in terms of x for number 2. One part is 8, the other part is given as x. So what would the total distance simply be? Yeah, go ahead here. 8 plus x. Make some expressions in terms of x. One part is 8, the other is x, so the whole part is 8 plus x. On 3, 4, 5, and 6, now you're given the wholes and one of the two parts. If the whole distance is 10 and one part is 7, what's the other? 3. The other part is the whole length minus the first part. On question 4, the whole length is given as x. One part is 4, so what's the other part? X minus 4. Why not 4 minus x? X is the whole and one piece is 4, so it's whole minus part for the other part. That would make 5 what then? On this last column. 15 minus x. 6 is kind of a challenge. I'm going to write each of these two expressions in terms of x. All I've given you is the whole part to be 9. The whole length is equal to 9. Let's call one length x. What would the other then have to be? 9 minus x. If the whole distance is 9, then the two parts written in terms of x would be x and 9 minus x. Do these two still add up to 9? Like 7 and 3 added up to 10? What is 9 minus x plus x? 9. 9 minus x plus x, the x to cancel out to just make 9. If the whole is given as 9, then the two parts would be one is x and the other is 9 minus x. We're going to practice some proportional relationships with wholes and parts today, so I thought it'd be good to look at those first. Questions there? All right, let me turn your attention to the other board then. Let me swing this around. Let's try this. Thanks, Bethany. We're going to look at proportional parts in triangles and parallel lines. So let's add this into our notes. First statement is what is called the triangle angle bisector theorem. To bisect an angle means to cut it in half. Make it into two equal pieces, one half and the other half. So in this triangle, triangle A, B, D, the entire figure, angle A is being bisected. Angle A is being bisected. It cut into two pieces, the top half and the bottom half. I'm slicing angle A with segment AC, and it cuts it into two parts, the top part and the bottom part. Since it's being bisected, each of those two parts are equal. Does that make sense? Bisect means to cut into two equal halves. And our theorem says that the angle bisector of a triangle divides the opposite side into segments that are proportional to the remaining two sides of the triangle. So this angle bisector, AC, cuts the other side, the right side, into proportional parts. BC is proportional to AB, as DC is proportional to AD. That angle bisector, AC, cuts the opposite side into proportional parts with the other sides of the triangle. Basically, it slices the entire triangle into two similar triangles. These two triangles are similar, so there's going to be lots of different proportions. BC is to AB, as DC is to AD would just be one of them. There's really just lots of different proportions because those two triangles will therefore be similar. Okay, that's the proportional parts of triangles. Let's look at proportional parts of parallel lines in this next statement. Parallel lines and proportional parts. If 3 or more parallel lines are being intersected by 2 transversals. So let's look at that figure below, see how this is being set up. 3 or more parallel lines, LO, MP, and NQ running left and right are all 3 parallel lines. And they're being cut by 2 transversals running from top to bottom on the left and right. Those parallel lines are therefore going to cut off the transversals proportionally. So those parallel lines are going to cut the transversals into proportional parts. LM is to MN. Top left is to bottom left. As OP is to PQ, top right is to bottom right, for example. Those parts are proportional as the parallel lines are being cut by the 2 transversals. I feel like a flight attendant. Wheel around my cart throughout the classroom. That's the way it is. Okay. Here's a few for us to look at. Let's write some proportions for the different parts of these figures. Question 1, I have the same 3 parallel lines being cut by the transversals, dividing it into proportional pieces. Those pieces are 9, 15, x, and 20. Not too terribly difficult. Give me a proportion you think I could use to solve for x with. Lots of different proportions you could write. Can you think of one of them and share?
15.
9 is to 15. And how'd you finish that up?
20.
Oh, yeah, got to be consistent, right? So if you go top is to bottom on the right, you better go top is to bottom on the left. I was thinking x is to 9 as 20 is to 15, but it's all the same. All the same, because you're going to find the same 2 cross products. X times 15, 20 times 9 makes 180. Help me out. What is 180 divided by 15? Use your calculator. Whatever. What is that?
12.
12? Yeah, that's right. 12 looks good. Number 2 is some more proportional parts. Where should we start? On the left, I have a length labeled as x, and the bottom given as x plus 12.
So x to x plus 12.
On the right, I have a length of 11 on top. This 33 is the total distance on the right from top to bottom. Where should I start? How can I use the 33, for example? Yeah, go ahead.
Would you subtract 11 to find the section?
Right, it's more wholes and parts. The whole distance on the right is 33. One of the 2 pieces is 11, so what's the bottom piece have to be?
22.
22, just the difference. Now I can compare proportionally. The whole distance is 33, one part is 11, so the other is 22. If I go x is to 11, what would that be proportional to on the bottom? Finish that up, Emma. Perfect. Now it's just the game of cross multiplying. 22 times x, 11 times x plus 12. See, that's 11x. What's 11 times 12?
32.
So I'll multiply and bring down 22x equals 11x plus 132. Minus the 11x to keep solving. Gives me 11x equals 132. Divide by 11, so it's got to be 12 again. How are you feeling so far? All good? Good. Try the other two. We did 1 and 2 together. Take a look at 3 and 4. On 3, you've got some parts labeled as 21, 9, x, and 14. Write a proportion to solve for x. Same on number 4. Sorry. What proportion could you write?
Destiny said that she didn't see anything on Google. So she said she doesn't watch it.
It's 2/3.
She can't. She was logged in a minute ago. She can't see what I'm saying.
So it's
Yeah, she said that she was logged in, she couldn't see anything.
Okay. Well, it'll be the same video when she logs in later. So.
shoot 21.
No, she couldn't like see anything she's doing.
Oh, I did.
So she's gonna watch it.
I did
Nine
9
over
over
recording now. So
I did 9 over 20.
I guess you watch it. See.
No, because it's lines. These are lines that are equal.
It's all wrong.
So 9 is equal to x.
So you're able to see my screen.
So it's the same thing. AB is 21. No, but AD is equal to AB. And AB is 14.
21 is to x.
So it's 21 is
What you do 21 is to 9. Compare the top two pieces.
X is 2 words.
You do 21 to 9. That'd be proportional to x.
Different sides.
That means you're doing this proportionally. You have to make sure you're consistent.
So X is
I go from left to right here. 21 to the 9. Go from left to right with what's on bottom. 14 to x. 21 is to 9. That's 14 is to x. Should be 12 though.
Is that
7.
oh, 5, so that's 8 minus 8. There X.
Then you can reduce that down. 40 and 12, you can divide both by 4.
On number 3, should you be more 14?
What's your proportion?
Answer my other question. Did you get a fraction? Yeah, I got 3. Yeah, 10/3. What's this number?
Just leave it that way. 10/3 is totally fine. That's how Khan would take it, so might as well just leave it the way it is. She couldn't see anything. She could also just should be 10/3, 3 1/3. Probably right.
Yeah. I was told you that.
Where is it now? Slowly, how are you? 4 minutes, then we'll put the answers up for us to look on together. Four is very similar, Sylvie, but I'm missing this part. What is this distance given as in terms of x? I'll solve from there. Here's if there was a Khan app on your phone, like Khan Academy. Someone downloaded it yesterday. I was going to remind people if they want to put it on their phone, they can. Max, what's your proportion for number 3?
I got B x over 5, 9 over x to 21.
Sure, 9 is to x as 21 is to 14. I was thinking 21 is to 9 as 14 is to x, but it's all the same because when you cross multiply, you'll match the same two pairs. So 21 times x. What's 9 times 14? Those of you who got this far.
126.
26.
Both showed up.
So cross multiply to make 21x equals 126. Divide by 21. Hey, we get 6 again. On number 4, I'm missing this piece here on the lower right part of the figure, but I can figure it out pretty quickly by knowing that the whole length is 8. One part is x, so the other part would be the difference, 8 minus x. Now how about x is to 5 as 8 minus x is to 7. Cross multiply, so 7x equals 40 minus 5x. What's next? Where'd you go from here, Annie?
I did +5.
Add 5x on either side, I would agree with that. 7 and 5 make 12. Yeah, what is 40 divided by 12? Let's see, I can reduce that down by 4. So 10 over 3. We're getting the third.